Ever feel like placing a bet, and you're almost certain to win?
Like the odds are so in your favor, it feels rigged.
That's what mathematicians thought about something called the Bunkbed Conjecture.
For ages, they thought it was a sure thing.
But guess what?
It turns out the house always wins.
We're diving into a mind-blowing new research paper.
It completely shatters this fundamental math idea.
And trust me.
You are going to want to grab a seat for this one.
So, for those of us who don't live in the world of abstract math,
Right. Not all of us are mathematicians.
what is the Bunkbed Conjecture?
Well, imagine two identical networks, one stacked on top of the other, like you guessed it, a bunk bed.
Okay.
And we're not just talking about like physical networks, but any system where things are connected,
Okay.
like social networks or even the network of neurons in your brain. The bunk bed conjecture is about how these connections form.
Okay.
It basically says a connection on the top bunk bed is at least as likely to be formed as the same connection on the bottom.
So, just picturing it in my head,
Yeah.
it feels like that should be true, right?
Right.
I mean, it's the same network, just vertical.
Exactly. It's so intuitive.
Right.
And for a long time, mathematicians were sure it held true.
Okay.
But proving it, that's where it gets really interesting.
Okay.
This wasn't just some, mathematical curiosity.
Right.
This conjecture, it could help us understand how all sorts of complex systems actually function.
So, like, what's at stake here?
Well, for starters,
Yeah.
think about how useful it would be to be able to predict how things spread through networks.
Okay.
Like, take disease spread, for example. If the bunk bed conjecture held true, we might be able to better model, maybe even get ahead of outbreaks.
That's a big deal.
Or how about designing more efficient communication networks? This conjecture, it's relevant there, too.
Interesting.
It's fundamental to understanding how connections form
Yeah.
and how those connections then influence behavior in all sorts of networks.
Yeah, it really makes you think about all the systems we depend on every day.
Right.
But if mathematicians were so sure this conjecture was true,
Yeah.
how did it all fall apart?
Well, this is where the story takes a turn.
Okay.
Remember how we said proving the bunk bed conjecture was the tricky part?
Yeah.
Turns out
Yeah.
it wasn't just difficult to prove. It was actually impossible.
Wait, hold on.
Yeah.
You're telling me this seemingly obvious idea that being connected on the top bunk can't be less likely than on the bottom.
Right.
That's flat out wrong.
Yeah.
How did anyone even discover that?
You're not going to believe this. Instead of proving the bunk bed conjecture,
Yeah.
these researchers actually disproved it.
All right, talk about a plot twist. So
I know.
how did they do that?
Well,
Did they have to invent some crazy new math to do it?
it was clever. I'll give them that.
Okay.
It all started by challenging a related idea
Okay.
in a different type of network.
Okay.
It's called a hypergraph.
Okay, before we get into the how,
Sure.
it's probably worth explaining what a hypergraph even is.
Yeah, so a hypergraph, it's like a way to represent these connections,
Okay.
but in a more abstract way
Okay.
than your typical network.
Okay.
It's like, imagine this. Yeah.
In a regular network, you've got your points, your nodes,
Yeah.
connected by lines or
Yeah.
edges.
Right.
But in a hypergraph, those edges,
Yeah.
they can connect multiple nodes at once,
Oh, okay.
not just two.
I see.
So it's a way to capture, like,
Okay.
more complex relationships between things.
More multifaceted.
Exactly.
Okay. But how does this hypergraph detour
Right.
help us with the bunk bed conjecture?
So get this.
Okay.
They found a way to arrange a hypergraph
Okay.
in a very specific way
Okay.
that actually violated a conjecture
Huh.
very closely related to the bunkbed conjecture.
Interesting. So, like,
Yeah.
it's like dominoes
Like,
if this one falls.
It hints that the bunkbed conjecture might be on shaky ground too.
That's fascinating. It's like finding a crack in the foundation
Right.
if this related conjecture could crumble.
Yeah.
It makes you wonder about the bunk bed conjecture, right?
That's really interesting. So
Yeah.
they are tackling this smaller puzzle
Right.
with the hypergraph.
Exactly.
And that is chipping away at the foundation
Exactly.
of the bunkbed conjecture.
It's like a blueprint.
But how do you go from this abstract hypergraph
Right.
to the real world of networks?
That's the genius part.
Okay.
They took that pattern,
Yeah.
the one they discovered in the hypergraph,
Mhm.
remember the one that violated that related conjecture?
Right.
And they used it as a blueprint
Okay.
to construct an actual network.
Wow.
Yeah, it's like they translated a language,
Okay.
took the logic of the hypergraph, and expressed it in the language of networks.
So they built a real-life version
Exactly.
of their mathematical object.
They found a way to bring it into the real world.
And what happened?
You know the answer to this.
Did it actually defy the Bunkbed conjecture?
It did. In this network, the Bunkbed Conjecture just didn't hold up.
Wow, so they found the one imperfection.
It's like that tiny imperfection in a diamond.
That makes you wonder what else is out there.
Right. Yeah.
So you said very specific network.
Right.
What do you mean by that?
I'll tell you what's really interesting.
Okay.
This network,
Yeah.
it's incredibly intricate.
Okay.
Thousands of nodes and edges,
Wow.
all meticulously arranged to mirror that initial hypergraph.
That's incredible. So complex.
Yeah, and it really speaks to the complexity of this problem.
Yeah, that kind of complexity makes it really hard to wrap your head around.
For sure. It's like a jigsaw puzzle where all the pieces look almost identical.
Right.
And you need to understand these subtle, tiny little differences to solve it.
It makes you wonder what else we are missing.
It really does.
If something like the Bunkbed conjecture
Right.
can be proven wrong,
Yeah.
like what other mysteries are out there? It really does feel like we've stumbled into a whole new world.
And it's pretty exciting.
Definitely. So where do we go from here?
Well, there are some big questions
Yeah.
now that we know the Bunkbed conjecture is wrong.
Like what?
Well, remember that super complex network?
The one they built to disprove the conjecture?
Yeah, that one.
Yeah.
Did it have to be that complicated?
That's a good question.
Is there a simpler example out there?
Oh, okay.
A simpler way to show the Bunkbed conjecture is wrong?
I see what you're saying.
Or is this just how networks work?
Like when they get complicated enough,
Exactly.
the Bunkbed conjecture just doesn't hold up.
It's a possibility.
I feel like we've uncovered this hidden truth.
Yay.
And now we need to figure out what it all means.
Yeah, and it makes you think, right?
About what?
About intuition.
What about it?
We looked at the Bunkbed conjecture, and it just felt right,
It did.
but we were wrong.
So you're saying we can't always trust our gut?
It happens.
Even in math?
Especially in math.
That's kind of unsettling.
It is, but it's also exciting.
How so?
It means there's still so much we don't know,
Okay, that's true.
and that we should always be questioning what we think we know.
I like that.
Always be learning.
So what's next?
Where could this lead us?
What are you thinking?
Control.
Control. What do you mean?
Controlling networks.
Okay.
In ways we never thought of before.
Because of this discovery.
Because now we know
Yeah.
it's possible for connections to be less likely.
And if we can control that,
What could we do?
it's like we're changing the rules of the game.
Exactly.
Give me an example.
Imagine a communication network,
Okay. I'm imagining it.
and you want to make certain connections less likely.
Why would you want to do that?
Security, maybe?
Okay.
Or to stop the spread of misinformation?
Right, that makes sense.
It might even make the network more efficient.
We're not just watching the network anymore.
No, we're shaping it.
This is mind-blowing.
And it goes beyond networks, too.
Really?
This kind of thinking.
The reverse probability thing.
Yeah, exactly. It could
Okay.
apply to lots of other areas.
Like what?
Epidemiology, finance, even AI.
Wow, so this is much bigger than just networks.
It really is.
So we started with this simple idea about bunk beds.
Right. And look where we ended up.
This is why I love these deep dives.
Me too.
You never know where they'll take you.
It's true.
But one thing's for sure,
What's that?
there's always more to discover.
Always.
And that's what makes it all so exciting.
I couldn't agree more.
Well, that wraps up another deep dive.
Another one for the books.
Until next time, keep exploring, keep questioning, and never be afraid to challenge what you think you know.
Yeah.